All right, so for these notes, we're gonna get some vocab down. We're also going to see how we could view each term in a picture, how we would write it, or try to type it, and then how we would say what it is that we're writing, okay? So our first figure that we're going to establish is what a point is. A point doesn't have any size, it's just a location in space. Okay, so you might see something that looks like this. Okay, those are three separate points. Let's say we're talking about this point. This is called point B. And we would just write it exactly that way. It's not too exciting yet. Just point B. How we write it and how we would say it for this is the same. The thing we want to make sure of is when we're talking about points, we're using capital letters. Okay? The next figure is a line. Lines are made up of infinitely many points. So if I put all the points together, it can form a line. Lines have arrows at the end, which means they extend infinitely. All right, so let's say we have this picture, and I'm only going to reference 2 points on the line. We only need 2 to know where our line goes. So let's say points C and D. And you could also use a single lowercase cursive letter to talk about the same line. All right, so we have a variety in what we could call or how we could name the lines. So for this line, we could call it line CD or line DC. The order can go either way. Or line M, and this letter is cursive lowercase. All right, and that's how we'd say each of those. So we want to see a little symbol that looks like a line, it has arrows, and you're telling me what points it goes through. All right, only 2 points. Next figure is a line segment. So these are different from lines because they have start and end points. All right, think of it as a piece of a line. So if I have this figure, this line segment starts and ends between G and H. All right, so we could write this line segment as line segment GH or line segment HG, and that's how we would say each of those. All right, and then again, notice a little tiny picture. It looks like a line segment. It's not going to keep going infinitely because there are no arrows. All right, next figure is a ray. Rays begin at an end point, and they extend infinitely in one direction. We name rays starting with their endpoints. Okay? So rays are like a hybrid between lines and line segments. So that could look like, let's say S is the endpoint. It's a ray going infinitely in the direction of T. How we would write this, there's only one way to write this because we start it with the endpoint. The endpoint is S. Our ray symbol goes that direction, and it's going in the direction of T. So we'd call that ray ST. All right, now opposite rays are just rays that share an endpoint, and they extend infinitely in opposite directions. So if you were to put them together, or if you just see them all as one, together they form a line. So let's say I have this ray U, W, starts at U, goes towards W, and then the ray that starts at U and goes in an opposite direction through V. So we would say ray UW and ray UV are opposite rays. They go in opposite directions. Okay. Now our next one, angles. So angles are composed of two rays, and these are connected at their endpoints. The vertex of the angle is that endpoint, and the rays form the sides. Okay? So let's say we have the angle formed by this ray DE and this ray DC. Even though these have the same endpoint, they're not opposite rays because this ray is not going in exactly the opposite direction, okay? So this here, we would say the angle is being measured here at D. This is the vertex. So we could write this angle by giving a little angle symbol, saying angle EDC, or we could do the reverse order, angle CDE, or we can even name it with the vertex and just say angle D. We couldn't do angle E, angle C, or angle CED because we want to see the middle letter is the vertex. That tells me where I'm measuring at. Okay? Our next word, planes. These are two-dimensional flat surfaces that extend infinitely in all directions.